So we are looking at logs today. We have looked at logs as graphs. Now we're going to look at them the algebraic way. So we're going to compare exponential functions, and then we're going to compare logarithmic functions. And we're just going to go back and forth, and we're going to solve them. Before we get into the solving, though, we do have to kind of build an understanding of what the heck is going on. And I also want to offer calculators. Who needs a calculator?
These.
For free? No, I need them back though. I grabbed a couple because ACT gets low tomorrow, so we gotta make sure we have them. So you will actually use your calculators for those logs today. And if you have a scientific calculator like the blue ones, I will show you how to utilize them. If you have the Casios, you actually have a little bit less work and you can get an answer pretty easily. If you missed the Chapter 9 test, I need you to make that up soon. So that means either today or Wednesday. All right. We have apparently the ELS 2 testing flu, which happens pretty much every time we have a test. Because I had about 19 people missing. Some of them talked to me, and that was fine, and I get that. But there's still about 10 people that just, in math class we look at patterns. It doesn't take you to be a math teacher to notice patterns. So we've had a couple tests, make sure that doesn't become a pattern. So sliding into this, we're not going to just solve these problems. There's no point. I know you know how to do them. We're going to talk about what is happening within that problem. So when I look at this very first one, to get the answer, I'm subtracting 2. So I get x equals 3. I don't care about the answer. I care about that. I also care about that. So I care about them in 2 different ways. One, I care about them because they're inverse operations. 2, what I do to one side, I do to the other side. That's going to hold true throughout all these. If I look at my next problem, I divide this by 2, divide this by 2, and I'd get x equals 5. Again, I don't care about my answer. I care about this. I'm doing the inverse operation. What I do to one side, I do to the other side. That's going to be a building block for a continuation of what we do today. Fractions we don't like, so I'm going to show that one. I would times this by 3, and times that by 3. That's canceling, just like this is canceling, and just like that is canceling. Again, because they're inverse operations. What you do to one side, you do to the other. You're like Nichols, you're sounding like a broken record here. That's the whole premise of today. If we can get that, our next steps become much easier. Sliding down, actually, to the next page. Same page for you. Squares. Here I would take the square root of both sides. And by taking the square root of both sides, the square and the square root cancel out. They're, again, inverse operations. What I do to one side, I do to the other. This one I do want an answer for because sometimes we mess it up. What's my answer? What? Not 9. It is 9. And? No. Well. Negative 9. Yeah, so we actually get plus or minus 9. Over here, we get square root of x. So we square it. So the square and the square root cancel each other out. Inverse operations. I square this side and end up with x equals 25. So again, inverse operation, over and over and over again. What I do to one side, I do to the other. Over and over and over again. We're just going to add a tool to your toolbox. We're now just going to give you the inverse operations of logs and exponential functions. And that's what they are. They're just inverse operations. So if I have an exponent right there, that's a variable. I could guess. Honestly, you can guess, and sometimes you can get the right answer. But just like those other problems, I don't care about the guess. I care about, can you systematically find that answer? So what do? What's my base here? 2. The base is the base of everything. This entire chapter is based on the base. No pun intended. It's all about that base. So we are going to have log base 2, and then I'm going to have an argument. And then I'm going to have log base 2 and have another argument. What goes in that argument? These things just drop in. So I get 2x right here, and I get 128. Now log base 2 argument of 2 to the x, that cancels out just like above. It's the inverse operation, leaving me with x. Then I get over here, and I get log base 2, 128. Now, the variable, the x, is where I want it. I got numbers on one side, I got the x on the other side. I can type that in my calculator. This is how it works. Over here, I get log of a divided by log b. This is called the change of base formula. So your calculator is base 10 for the logs. Our base here is 2, so we can't just do that. So to type it in, I type it in like this. Log base 128 divided by log 2. Now, when you type this in, do not forget that parenthesis right there. When you type in log, it kicks up a parenthesis. You have to close that parenthesis before you hit divide. Okay? I want you all to try it. Make sure you can get that number. And the number is 7. So you need to get 7. If you don't get 7, please ask and I'll walk by and just double check things for you. Again, the most common mistake is simply not closing that parenthesis. And sometimes people just forget to type log one more time. So I get x equals 7. Question? Next one. Now we have a log. I also think of this unit not just about the base, but this unit is also about what don't I have. So this problem, I have an exponential function, I don't have a log. Chances are I'm using a log to solve it. Over here I have a log, so what don't I have? I don't have an exponential function, so chances are I'm going to use an exponent to solve that in some fashion. And this is how it works. I take this, and what's my base again? 3. So I actually write this like this. My base is 3 for both of these, and the stuff that I have right there becomes my exponent. So that is called exponentiation. I'm taking what I've had and making it into an exponent. What happens? Well, the same thing that happened right here happens over here. Base 3, that log base 3 cancels out, and I get x equals 3 to the 5th power, which is 243. Really hoping someone had it. I know, no calculator. Keegan is.
How am I supposed to do that? Like in mobile?
You don't have to. It was just like a little bonus if you could. So that's what we got. Questions so far? It is just another inverse operation. It's something you've been doing for a long time. I went too fast. I'll wait. Does anyone need this yet? I do want you to have it down if you need it. Okay, then I'm going to go to the next page. So it's still the first page. This is on the bottom. So in general, what does it look like? You're going to be asked to do this on your homework. Basically, can you change forms? Not solve anything. There's no way I can solve for b because I don't know x and y. I'm just asking you, can you change forms? So let's change forms. Inverse operation here is going to be a log. What's my base? What letter? B. So I'm going to have log base b, and then I'm going to have bx, and then on the other side, I'm going to have log base b, and that's going to be y. So what happens, the b's cancel with the log, and I get x equals log base b, argument y. So I've changed forms. Does my base ever change? Whether it's a log or an exponential, the base is always the same. Notice what happens. It's simply the x and the y just rotating. When you're changing forms, that's it. Let's look at the next one. So I got a log, so the inverse function is an exponential function. So what's my base here? B. So I'm going to go B, and I'm bumping that up. I'm making that an exponent. Be very detailed about that. Do not write it in line. It is not written in line. It is your base, and then up above that, there's an exponent. So this is going to be b to the power of log base b, argument x equals b to the power of y. Inverse operation, this cancels, leaving me with x equals b to the y. Notice again what happened. Your exponent is y, and the x rotated. My base did not. My base is still my base. The other thing I'll also point out is logs equal exponents. So it makes sense that that exponent is right there. You ready? This is where the fun begins. This sounded kind of devious there, Nichols. This is where the fun begins. It could be a Star Wars reference because we're traveling light years away. All right. Well, hello there. That was another Star Wars reference. It wasn't never mind. Dude, just get back to TV. We're gonna have to get you a bigger shirt. Example 1. If I wrote up there on the board, I'll write it on the board since we're taking the video there. If I wrote 4x plus 5 equals 13, you'd know how to solve that, right? That's basically what this problem is for the first part. Okay? The first part of this problem is the same as the first part for number 2. The first part is get the log by itself. The first part over here is get the 2 raised up to the power of x by itself. So let's do that. First step here is going to be what? Perfect. So we're going to subtract 5. And our next step is divide by 4. So I'm getting my log by itself. That is the first goal. I want to get rid of my log because my argument is right here. Some of you might actually know the answer to this problem, and that's fine. I don't really care about the answer right here. I care about how do I get to the answer, the process. And so in terms of your test, we might give you something like this, okay? And that would be because we're giving you a breadcrumb so you can kind of check your answer easier and have some intuition about what it should be. But if you would just give me the answer, I wouldn't give you really that many points because your test, you start at 0. And everything you do earns points to get you points, all right? So don't just jump to the answer, show what's going on. When I look at this, what's my base? 3. So I'm going to write this as 3 with an exponent of log base 3 because I want to get to the x that's in the argument, so I have to get rid of my log. Then over here I'm going to have 3 with an exponent of 2. I just took those 2 items and I just pushed them up. So we got this. What's left on the left-hand side? X. 3 squared is what? 9. That's your first log.
What if you just fill in 9 for?
I think there's so many moving parts. It's scary.
Because I want to just focus on that, all right? So think about what we did. This, not really new. You've done those steps before. You do them again, you'll be fine with them. This, down here, is the new step. Can you cancel a log out? Can you do the inverse operation for a log? So you're learning about 10% of something new in terms of the entire problem. Let's dive to the next problem. What do you think your first step is? Add 1. What do you think your next step is? Yeah, it's pretty common to have something like that. Plus 1 divided by 3 or minus 1 times 2 or something like that. Those are the steps we typically get. So I'm going to plus 1 to both sides. And then I'll divide by that 3. So inverse operation cancels out. Inverse operation cancels out, leaving me with 2x equals 1. I purposely wrote my 1 a little further over. How do I get that? Now you might know the answer. Anyone know the answer? 2 to what power is 1? 0. It's actually property right there. But let's make sure we can find it, because I guarantee you on the next couple of examples it's not going to be so nice. So if I look at that, what's my base? 2. Notice I'm always asking the same question over and over again. I'm asking, what's my base? What's my base? What's my base? For this problem or that problem? That's all you got to know. You got to know your base to start. Now I have an exponential function. I want to get my exponent down. Logs equal exponents. So I'm going to have log. I'm going to do this in a different color. So log, parenthesis, around that. Now it is base 2, so I'm going to say log base 2. Then over here, I'm going to have log base 2, argument to 1. So we do our cancellations. On the left-hand side, I am left with x. On the right-hand side, you can calculate that. You get 0. Typing it in your calculator, remember, you would type it in like this. 1 divided by log 2. And that kicks out 0. So 2 to the 0 power gives us 1. Works out. Questions? Make sure you get this down. So write it down if you need to. I'll wait for a moment. And then we will move on to the bottom two problems.
Why do we switch a riser 1 divided by 2?
Oh, you always do the log of your argument divided by the log of the base. And we switch it because when you hit log on your calculator, it's actually log base 10.
Oh.
And obviously our base isn't. So it's called the change of base formula. We good?
Why'd you do all that extra work?
So I'm doing the extra work because this is what we care about. And so sometimes it's better to see something where you know the answer, see how you get there, than it is just to see something crazy. Because we're gonna get to crazy in a little bit.
What do you call that?
allergic to that. Funny, you got those. Bless you. That was crazy. Next, number 3. See, now we get a little not so nice.
Yeah, that's actually a lot. Dude, this is actually crazy.
What would be your first step?
Eliminate that 4.
Add 4. Yep, eliminate the 4. We're going to do an inverse operation to get that 4 to the other side. So that cancels, and I get 2 log 7, then 2x minus 3 equals 4. Next up, you're going to divide by 2. So we haven't really done anything that would be considered new yet. So the log has the variable in the argument. So because of that, I need to change forms. To change forms, I'm going to do an inverse operation to get rid of that log. So what is the question we always ask ourselves? What's the base? So it's 7. So I'm going to do what with the 7? Am I going to take a log base 7 of a log base 7? No. So I'm not going to use a log because I have a log. So instead, I'm going to raise that up as my exponent. So I'm going to write this as 7 to the log base 7, 2x minus 3. And over here, this is going to be 7 squared. Again, notice, what was there just gets pushed up as your exponent. So we cancel. And I'll wait just a little bit so you can write and catch up. So I cancel this, and I'm left with 2x minus 3 equals 49. So notice the inverse operations we had. This was an inverse operation. That was an inverse operation. This is an inverse operation. We just had 3 inverse operations. Question.
Are they always gonna be nice where it's like the log always being canceled out? Where when it's like with parentheses like that?
Like this?
No, like where you always cross out
This
logs
right here?
Yeah, and then it's
Yep. So as long as my base here matches the base of the log, they always cancel out. And it just goes away. Just like if I have x plus 2, I will always minus 2, and then that always goes away. Does that make sense or no? Kind of? Keep asking if it don't. Yeah. Give me an answer for that.
26.
26. 26 is correct. X equals 26. Look at that detail. I like it. So x equals 26, which is also how many pay periods are in here if you're on weekly pay periods. So we got that. Questions on example 3. This is brand new to you, so I want you to ask. There's no bad questions right now. Example 4. First step, add 7. Next step, divide by 5. There's patterns developing here, folks. Not saying that that is always going to happen, but it's pretty dang close.
Behind or something.
like
So that part is not what I would consider new, right? You're just getting something isolated. You've done that for a while. You tell me what to do on this problem. Now, starting at that point.
Put the 2x plus 1
How am I going to do that, though?
I don't know, whatever you done.
I'm going to do what, Wendell?
you gotta do log sum.
He didn't even say anything. He said, how do you do that?
Oh.
I was like, wait, what are you talking about?
You gotta do log
I do have to take a log.
log 2.
Log 3.
Log 3. My base is 3. So I'm going to take log base 3. That's my argument.
You know what I was trying to get at now.
I'm going to take, I'm going to erase that and then rewrite it. I'm going to put log base 3 of 27.
I bet that log 3 and the 3 are gonna cancel out, so it's just gonna be 2x plus 1 equals 27. Or not.
2x plus 1 equals log base 3 argument 27. Now, 3 to what power is 27? 3. So if you know the answer, you can put 3 down. If you don't know the answer, at that point, I'd say grab your calculator. And would you type in log 3 divided by log 27 or log 27 divided by log 3? Log 27 divided by log 3. So you always take your argument that goes on top. And don't try to overcomplicate it, because if you think about it, what number is above the other number? The argument is above the base. So the base is your base again. It's the bottom. It's in the denominator, and your argument is on top. So we get 3 right there. Go ahead and solve that for me.
Is it?
It is going to be 1. So I would subtract away 1 from both sides, which gives me 2x equals 2. And when you divide, you get 1. Questions? How do we feel like we're doing? Do you think you could do a log on your own? Do you think you could do an exponential function on your own?
Yeah.
All right, don't flip the page yet, because there's one thing on the bottom of that page that we got to talk about. Common log or common bases, I should say. So we have log x. If I wrote, and you've actually been doing this for a while, if you take the square root of something, what number is right there? 2, because it's the square root. That's why when I square this, my exponent properties actually make that cancel out. You've been doing that for a while. So when I have log x, that is the exact same thing as log base 10 x. So logs, we do a lot of calculations with base 10. Because of that, that's the button on your calculator. That's why we do a change of base formula. That's why when you have log base 2, that's why you take like log of 15 divided by log 2 to get an answer. Because otherwise it's doing it as a log base 10. ln, not in, ln is log base e. Now I told you before, we use e a lot, and because we use it a lot, actually just give it its own button. There's a lot of things that happen with e. If you ever get the chance to make it to calculus, e shows up a lot. It's a really cool thing actually. We're not going to dive too far into that, but when you see ln, it just means log base e. I don't want you to write log base e, I just want you to write ln. Be as efficient as possible. We do expect you to know that. So you can utilize your notes to remind you of that when you're doing your homework, but get used to it. All right? Questions? Yeah. I could actually.
No, like I'm being
I could. Example 5, what base is it? Base 10. I want you to do that one. Get rid of the 2 right off the bat and then try it out. You don't have a trig yet. You haven't taken trig. So you're taking trig next year.
Is this a basic math class? Is that a basic column?
What, trig? I would say it's basic. You might actually start with college algebra and then go to trig. And then college algebra is the same as algebra 3. I've actually taught that before. So what base is it? So 10 is your base.
Is college gonna be a part
So
of
how do you cancel those?
It's gonna be school time.
You gotta
I'm there to do
make it
Fast.
fast.
If I just get to work.
So,
I'll solve this.
so if this is log 2, you put log 10 on here, or what? No.
And you're back. Okay. So this was like base 7. And then I put 7 in my base and I made that. Try that.
So you said when there's no like base with it, it's 10.
Correct.
Okay.
It's easy when he writes it up there, but like, I don't know how to get there. When he does it right.
That's part of the 100, right? Use that and maybe get to work on the first one. Great.
Top the cap, right?
You know, the other one.
What did you get?
97.
Well, guess what?
It's right.
Yes.
No, that's right.
Yeah, I know. But no, that.
Work for you, Mr. Nichols?
I would have already been Mr. Nichols. I had a D.
Folks, that's the work for the first one. I saw a lot of good things as I walked around, so that was comforting. We are going to do example 6. It's a short and sweet one. Tackle that one if you can. Try it out. And then we're only going to do one more problem. We're going to do number 8. So if you want to jump to that, if you're waiting, go for it. Otherwise, number 8 is actually telling you a story. We're going to talk about that story.
So is this right here where you do it for log base A versus log base B? So it's just log base A and log base B.
Yes, but under calculus, this is log base 10. So you just say log 1,000.
So log 1,000.
And you don't have to do anything else because you have to show your base.
That's it? That's all it does? Because I finally figured out what this the regular log button was. And then it's zero. So this right? Because this one only ever lets me do that.
Yeah. I would use that.
So that's right. So then,
What?
because if you do, go back here.
Yeah.
Oh, it is. Yeah, it's that. Okay, so, okay. Well, like what I'm doing, like, the division stuff, I was trying to do it that, and it was getting weird. Literally, all you do is put.
I got my 10 log here, so do I cancel?
You just cancel it out, do x equals log base 10 to that. Boys, my calculator's probably classic. That's why it's right, it's right, it's right. Absolute cinema.
What do you do? I don't know. Did you just say absolute?
Absolute key.
I heard that on, hating on me is that Survivor. And I heard this person say it, absolute cinema. My wife and I looked at each other, and she's like, "Do kids actually say that?" I don't think so. But maybe I'm wrong.
Or like an Instagram reel, like comment section.
Whew, okay. Well, okay. Folks, what log do I use? Yeah, I just use log. I don't even have to write anything there because it's log base 10. So I take the log of this side, and I take the log of this side. I'm going to sneak that in there. And that just cancels out because it is log base 10. So I get x equals log of 1,000. Now, your calculator, again, is in base 10. You don't have to do a change of base form here. You just type in log 1,000 and hit enter. And what do you get? 3. All right. So when you take a look at this, don't overcomplicate it. Sometimes you have to do a change of base. Sometimes you don't. Questions? Number 8, for example,
7 first?
we're not actually going to do 7.
Dude, I already got started on it. I don't know how to do it.
So number 8, yeah, you don't.
I don't know how to fix the last part. How do you actually put in the base and then the log button?
You know how when you're up in like Britlet or something, and they tell you, your teacher's like, so what is the author telling us? That's between the lines. And you're like, nothing. They wrote the lines. That's it. That's always what I thought. I was like, okay, they wrote this, so that's what they're saying. They're not trying to go for anything else. We're getting into a weird place when we're just making stuff up. You can tell them that upstairs. Tell Mr. Teskey that. Mainly because he had me. I liked him as a teacher. Regardless, so here we go. This is the story that problem was telling us. It is telling us that we use PERT, that formula. What does that formula get used for? What? It can be used for population stuff, or it can be used for money. This would be the money version. Continuously compounded interest. Let's take another thing at this. This is 50,000. This is 100,000. We've doubled our initial investment. That's what it's saying. So the question becomes, how long did it take us to double our investment? How long do you think it takes to double an investment like that? 20 years? the last class told me, maybe like 3 months.
No,
And I like 20 years as an answer because if it was 3 months, how many of you have a job? Why would you not take your one paycheck, put it in an account, and 3 months later double it? And then you would double that in 3 months, and then you would double that in 3 months, and so on and so forth. Why would you not do that? So it does take time. Now, compounded continuous, we don't actually get very often in finance. So it might be a little bit quicker, but let's just see. Lane, did you have a question? Okay, you were just, all right, thank you. So I already told you you're doubling it. So if I take 100,000 divided by 50,000, I'm going to get 2. All right, so let's just go ahead and write that down. So I'm going to have e to the 0.09 t is equal to 2. So we're just simplifying it because we know we're doubling. Now, my exponent has my variable. That is screaming at you, or maybe just talking to you. It's telling you to use a log. What log do I use for e?
log of
The ln1. So ln is a button on your calculator. You don't have to do anything fancy here, no change of base or nothing like that. So I'm going to take the ln of both sides. What I mean by that is when I type this in my calculator, I actually just type in ln2, enter. And I'll also do this side. That crosses out, and I get 0.09 t equals, what'd you get? 0. ln is, you're not hitting center or anything first. It's just 2 buttons down. You just hit ln and then 2. And when you hit enter on that, it gives you
0.693.
okay. 0.693, and then there's a 1 and some other stuff. I don't want you to write that whole number down. But I don't want you to clear your calculator either. What I am wanting you to do is leave breadcrumbs of showing me what steps did you do. So you just showed me that you calculated this. Now, don't clear that. Leave that so you're not rounding anything. And then divide that by 0.09 to get t by itself. And what'd you get? Greg, what'd you get?
7.702.
All right. So this answer, is it rounded? Your final answer? Yes. So our final answer is rounded to 3 decimals, to the thousandth place. That's what I'm going to be looking for. I expect you to round these answers, again, to the thousandth place. I don't want you to round that number, but I want you to write something down so like you're leaving, again, a breadcrumb, a trail showing the logic that you used and what you did. And I can look at that. I can look very quickly, and by looking at these 3 decimal places, I basically know the number you have in your calculator. So I don't want you to retype it, I just divide by 0.09. And you're good to your answer. Does that make sense? Okay, so this would be, if I'm reading into the problem, this would be years. So it takes 7.7 years, roughly 8, to double my investment. That's if I'm compounding interest continuously. We don't really do that. So we don't really double our money that quickly. But it's just something for you to think about. I did not actually have any units or anything like that, so I'm not going to put years there to make something up. So that's what we got. Questions? I want you to leave your note packets out, but I want you to get your homework packet out now. And I want you to look at the very first couple of problems. I'm going to help you with the first 2. I'm going to help you with A and C, so to speak. So really, the first problem, which is 3x minus 1 equals 9. The directions tell you, do not solve. Change forms. So let's change forms from exponential to log form. What's my base? 3. So I'm going to take log base 3 of both sides. So I'm going to slide this 9 over. Cancel that out. And I get x minus 1 equals log 3, then argument to 9. I'm actually not going to do anything else. The question is really just asking you, can you change it? And we did. We should add 1 over, but that would actually be solid, right? Because I'd have an exact answer if I added the 1 over. I don't need an answer. I just need to know that you can change forms. If you drop straight down, now it gives you log base 3. And I just gotta see what's here. 243 and then 5. You're not even finding anything, right? It gives you all the numbers. We're just changing forms again. So how do I get rid of this log? What's your base? So I go 3 as an exponent. Now, in the previous problems, I would rewrite this. I'm okay if you write it like this, as long as you understand this piece right here and this piece right here are now exponents. Once you got that down, you cross off, and I get 243 equals 3 to the 5th power. Done. Again, I'm not solving that. So those first 4 problems you're not solving, you are simply changing forms. So you only got 2 left. The rest of your homework is going to be a lot of solving.